Okay guys, so today we are going over what is a vector. So we have two kinds of physical quantities in physics, and these are scalar quantities and vector quantities. So first, let's start with scalar quantities. So these scalar quantities, they're quantities that you only need one piece of information. So if we say m equals 5, that's enough. It's one thing. So as you see here, it's just one thing, just like the A. That's how I like to just simplify it, and you can just tell from that. Singular thing, it's the simpler one. And scalars can only be added scalars, so you can only do so A plus A equals just say B. But you can't do A plus vector A. You can't do that. Okay? So then we have vector quantities. Vector quantities are quantities that you need two pieces of information, and they are shown by this. So this is A, and this right here is showing that it's a vector. It's a vector quantity, this arrow over top. Now this is often, see where I'm writing right here, this is what I like to do, but also you can see it as just a line on top sometimes, like that. There's multiple ways, but for the most part, just say this arrow is the most simpler, most known way. So the two pieces of information you need are the magnitude and the direction. So just like before, where a scalar can only be added to another scalar, a vector can only be added to another vector. So you can do vector A plus vector B is going to equal vector C. But you cannot do vector A plus the scalar A, whatever the value of that is. You can't do that. You can only add a vector to another vector and a scalar quantity with a scalar quantity. And you cannot add a vector velocity with an acceleration vector. Okay? So let's go over some of the correct equations. So like we said, vectors of the same type can be added. So R1, so we can say vector R1 plus vector R2 can equal vector R3. And here we're playing with delta. This little triangle right here, this means delta. And it means the difference between two vectors. So delta vector v will equal vector v2 minus v1. So if we were to have, this is vector v1, and this is vector v2, v2 minus v1 will equal the delta v. So right here, this is your delta vector v, okay? Now let's see some incorrect equations. So incorrect equations would be vector A plus 5 equals 3. Now why can that not be true? Because vectors can only be added to vectors. So you cannot add a vector quantity plus a scalar quantity. You cannot do that. So to do this, to say you could do a scalar quantity such as 2, so 2 plus 5 equals 3, that would be fine. Yeah, but the next one. So vector v plus vector v equals 3. Now that seems like it may be correct, but it's not, because two vectors cannot equal an scalar. Cannot equal a scalar. So you could do that vector v plus vector v equals vector c, just say, or you could do 1 plus 1 equals 2 if you want to do two scalar quantities, but you cannot have two vectors equal a can have two vectors equal a scalar number. Now last one, vector v plus vector a equals vector d. Now why is this incorrect? Because you cannot add different types of vectors. So in this case, this would be the vector velocity. This would be the acceleration velocity, and this could, acceleration vector, so this would be, vector v plus vector a equals vector d. You cannot do this because different types of vectors cannot be added. And so in this case, specifically, this would be the vector velocity, this would be the acceleration vector, and this could be the direction vector. So you cannot add them, okay? So let's see this first one. This has to do multiplication. So vector A equals vector A, so they're always the same amount. What is 3 vector A? So we are essentially multiplying 3 times vector A. So this is regular vector A. Now they're asking for 3 times of it, so we're just going to do 1, 2, 3, literally copy and paste, and this thing is going to be our 3 vector A. So it's a vector that has 3 times the magnitude of A. So the magnitude is like this length here, right? So if we were to copy and paste this, which is what I did, the 1, so 3, what do we say the magnitude is? The length. So here's 1 of them. So here's 1, 2, 3. It's 3 times the magnitude. And it's in the same direction. It's going this way. Now, if we were to go from here to here, it'd be changing direction, but we're not there yet. Now we are. Question 2, if vector A equals vector A, so if they're the same, what is negative 1A? So if this is positive A, negative 1A would be the same exact thing, but in the opposite direction. So the opposite direction would be going here. Now, if regular vector A was here, the opposite would be here. So A is the opposite slash flipped version. That's fine. Negative vector A is opposite or flipped version of vector A. So, and now we have this final example, number 3. So it's asking what is negative 3A. So we're going to take what we learned in question 1 and question 2. So first we're going to find what 3A is. Remember what we said for 3A? It's the vector of A, but 3 times the magnitude. So if this is A, we're going to do 1, 2, 3, and that is what is here. Now it's saying negative. What do we say negative means? Negative means going the opposite direction. So this was our positive 3 vector A, and the opposite direction is right here. So this is negative 3 vector A. Okay? I hope this video helped you understand exactly what is a vector. It's very important to understand what a vector is because it's essentially the core of all of physics. So, hope this helped you. Bye!